So today we will showcase CCNA level OSPF. So for this example, let's say we have PC1 here. And these are just going to be very basic networks. And the one PC is going to represent network A. Another PC might represent network B, that kind of thing. And we'll use very simple devices as well. So for example, maybe we have something like this going on. I'll put a router here, another one here. Alright, so let's start off there. I'm going to add another few switches and end user devices. So we're going to start off with something that looks similar to this, and just pretend that behind this switch is multiple PCs and printers and servers, but just for simplicity's sake, we'll have our topology look like this. Alright, so as far as connections, we will use crossover from our PC to our switch. Straight through from our switch to our router, and from this router maybe something like hazards. I'm going to try to match up the ports here so it's just easy to remember. 01, 01. Alright, so let's start off with something like this. We have a network here on this side, on the left side here, a network on the right side. And connecting these two routers, it could be a serial connection, but just to make it simple, it's just let's just say it's just a regular cable. Let's add some networks. So we'll make this one 192.168.1.0/24. Let's make this one 192.168.2.0/24. And this connection between these two routers can be something very small. So as far as subnet goes, we'll say /30. That gives us two subnets because we only have two devices connected on that network. So let's move this down some. All right. So what we'll do is we'll make the PCs the first IP of the network, and we'll make the router the last IP of the network, and we'll just make this one and this two as far as this 10.10.10.0 connection. So let's start off with this side. We will make the PC, let's see, config. We'll make the default gateway the last IP of the network, 192.168.1.254. I'm going to make the PC the first IP of the network, tab and /24. It's perfect. So PC is ready. As you can see, this link isn't ready. Links going to routers are off by default. So let's get that up and running. I want to say no for initial configuration, enable conf t interface G 0/1. We'll say IP address 192.168.1.254.255.255.255.0. No shut. Boom. To make this connection not faster, but make this spanning tree event faster, what we can say is enable conf t interface G 0/1 spanning tree port, and that just disables the listening and learning phase of spanning tree, and automatically enables it into the forward mode. So do right to save. Now, hopefully, our router and PC and our first network can communicate. There we go. The first little ICMP packet is lost due to the ARP request, but if we try it again, then it's 100%, so we're good. All right. Now let's go ahead and configure this network as well. So we're going to do the same exact thing. We'll go to the configuration setting. Default gateway of this network is going to be basically the same, except the third octet is going to be 2 instead of 1. All right, and 68.2.1 tab, and it defaults to /24. Perfect. So PC's ready. Let's go ahead and 0/1. We don't really have to configure anything on the switch for this lab, but enable conf t interface G 0/1 spanning tree port, just to get it up and running fast when I turn on this interface. You wouldn't want to use that command on anything that the switch is connected to as like an end user. Just because it could cause problems. It bypasses some of the security features of spanning tree protocol. All right, no enable conf t. Let's say, okay, 0/1. That's right. Interface G 0/1. IP address, and it's going to be the last IP address of .25.2, 255.255.255.0. No shut. Do right. All right. And let's get this up and running as well. So this is interface G00 on both routers. So we'll say interface G0/0, IP address. We'll use 10.10.10.1, 255.255.255.2 because it's A/30. No shut. Do right. I said no shut, but it's still red because this router needs setup as well. So with this router, we will do the same thing. Interface G0/0, IP address 10.10.10.2, 255.255.255.2. No shut, and you'll see that it goes up this time. But if we show IP route, all we have in the routing table are directly connected interfaces and locally connected interfaces, routes. I'm sorry. So network 1, even though all these interfaces are up, network 1 would not be able to communicate with network 2 without either static routing, just going into a router and putting in a manual route basically to this network, and vice versa to this network from this router, or using something called a dynamic routing protocol, which there's multiple dynamic routing protocols, but today we are going to focus on using OSPF. So with OSPF, um, we will go to configuration terminal. So we're on this router here. We are going to say router, and you can push question mark. Here are some examples of routing protocols: BGP, EIGRP, OSPF, and RIP. We want to use OSPF for this example. Let's go ahead and push question mark again. Process ID, we'll make it 1. And then carriage return, so that's as far as we can go. Enter. And you'll see we're no longer in configuration terminal, we're in config router. So let's see our options. All right, for this lab, we'll just focus on network. Basically all for this. Network and router ID. So let's give this a router ID. All the router IDs have to be slightly different, or the neighbor adjacencies won't form. So in order for OSPF to work, router IDs have to be unique. So this one's going to be 1.1.1.1. Sorry. Okay, we'll make network. We'll type question mark, network number. So it's basically any network that you want to broadcast from this router that's directly connected to any interface on this router. So this interface is directly connected to .2 via this interface here. So we can say 192.168.2.0. And the subnet's a little bit different. It's basically inverted. It's something called a wild card. So it's really the opposite of what a -24 is. So that would be all network portions being 0, with the host portion being 255. Area, let's say, is going to be 0. The area has to match on all routers in this OSPF example, or it will not work. So say do right. As you can see, even if I try to ping PC1 here on 192.168.1.0 from 192.168.2.0, anything in here, it will not work because only one router is participating currently in OSPF. This router isn't participating. This router isn't participating. So, and just as a demonstration, we'll try to ping 192.168.1.1 and destination host unreachable. Whenever you get that message, that means this router is saying, hey, I am trying to talk to this network, a device on this network, but I have no way of getting there. So even if you look at the the routing table, you'll see that there's still no update here. Okay, in order for us to be able to talk to this network, we will now configure this router as well. Oh, I'm sorry. I have to include the 10.10.10.0 network as well. So I'm going to add another network on the first router. And it's going to be 10.10.10.0. Wildcard is going to be 0.0.0.3, area 0. Do you right? All right. Let's set up router 0. Okay. We'll start off router OSPF1 question mark. Oh. Okay, sorry, I was in config interface mode. Let me get out of that. Let's try that again. Router question mark OSPF1 question mark carriage return question mark again. We want network, and let's include first this network. Oh, actually, let's go ahead and configure router ID first. We'll make this one 2.2.2.2, so it has to be unique. We can't use 1.1.1.1 because this router is already using that. All right, so let's go ahead and configure networks. Network 10.10.10. I can't spell. 10.0.0.0.0.3 area 0 question mark. All right, and let's include this network as well. So we'll say network 192.168.1.0 0. Uh-oh, okay, that's this log message. All right, that's okay. This is actually what you want to see anyway. This means that, hey, these two routers have paired via OSPF neighbor adjacency. They're now able to share routes, data, etc. So now they're able to communicate, which means once I enter this network, in theory, network 2 can speak to network 1 and vice versa. So let's go ahead and enter that network. 192.168.1.0.0.0.255 area 0. Do right. Okay, that might. Let's see if I can talk to the other network now. So there we go. We are able to talk to network 1, and it should work vice versa as well. Ping 192.16. Oops. 192.168.1. Oh, oops, sorry. 2.1. And there we go. We are in. And I'll show you also to show IP route. This route here, the O, basically symbolizes that there is a route from this router that this network can use. It basically goes through 10.10.10.2 to this 192.168.2.0 network. But yeah, anytime you see O, there's actually a legend up here. O is OSPF. And this one should have something similar, except it would have a route to the first this network here. So yeah, it's basically saying there is a route to 192.168.1.0 via this network here, the 10.10.10.0 network. Yeah. Another useful command you can use is you can say do show IP OSPF neighbor. I think it's neighbors or neighbor. I'm not sure if it's okay. There it is. Let me see if I try to say neighbors, would it work? Okay, it says invalid. Okay, yeah, so it's just neighbor, and you can see this full neighbor adjacency formed between these two routers. All right. And let's say in the future, I wanted to add another network. Let's say, for example, this is going to be a new network here. This will be network, just for simplicity's sake, 192.168.3.0/24. And the network connecting these two routers is going to be 10.10.11.0 and /30. There we go. Because you would have to have another network connecting two routers, and this very well would probably be a serial connection. Like I said, for simplicity's sake, let's just make it a typical regular Ethernet connection here. So 0202. my copper straight through the network router to the switch. Oh, well, that works. And my crossover. Let's just use fast Ethernet 1. All right. So we'll go ahead and make this PC. We'll give it the default gateway of 168.3.254. So the very last IP of that network. And we'll give the PC the very first IP of that network with the /24. PC is good to go. All right. We'll make the switch use Spanish report fast for interface 0/1. All right. So when I set that router connection to the switch up, it will automatically tone. It would be basically an up state, able to forward messages. All right. So G0/0. Oops. IP address. We'll make it the last address. 255.255.255.0. No shut. Do right. All right. That connection's ready. And these two connections here. We'll make one. We'll make router 1.1 first IP, router 2 the second IP. So let's go ahead and get started on that. So enable. Oops. Interface G0/2. Let me just double check. I think it's 0/2. Yep. And there's certain protocols you can use that will tell you, but we're not going to do that on this video. Let's say IP address 10.10.11.2 255.255.255.252. No shut. Do right. It's still down because the other side of that connection is down. So let's bring that one up. We'll say interface G0/2. Interface G0/2. IP address 10.10.11.1 255.255.252. No shut. Do right. All right. So now, even though these have a OSPF neighbor adjacency, this router isn't using OSPF. Let's go ahead and see what its routing table looks like by default. I do show IP route. And you can see it only has the connected and local routes. That's not going to help us if we want to talk to network 1 or network 2. If we ping from network 3, we would get basically a destination unreachable. So let's have this work. Let's have router 2 utilize OSPF and form a neighbor adjacency with the other two routers. So we'll say exit. Router OSPF 1 ? We'll say, let's give this router an ID of 3333. All right, network, and we want to include every network that's connected to it by an interface. So we'll use the, if I connect this one first, it will give me the message and it will cause me to not be able to finish a line. So I'll do this network first, 192.168.3.0, and we will use this wildcard of that for the subnet 0002555 area 0. Areas have to be the same. You're right. All right, and then let's add this connection as this network as well that's connecting the routers. When I add this one, I will get this syslog message stating that there was a neighbor adjacency form between the three routers. So area 0. Boom. It's going to take it a minute, but you'll see it. And it'll pop up on this one as well, most likely. Let's give it a minute. Let's say do show IP OSPF neighbor. See if okay, it hasn't formed yet. Oh, okay. You know why it hasn't formed? Because I also have to add this network to this router as well. So let's go ahead. X0/2 interface G0/2 router OSPF1 network, and we're just going to add this newly added network here 10.10.11.0.0003 area 0. Do right, and in a few seconds we'll get that syslog message basically stating neighbor adjacency formed. So there it is right here. This is what we want to see. So if we just double check, do show IP OSPF neighbor, we can see that the other two routers are fully participating in neighbor adjacency via OSPF, and we should be able to ping every computer from each other computer. So ping 192.168.1.1. It's going to take it a minute because it has to ARP and do this magic network stuff. Request timed out, request timed out, request timed out, and oh no, well, that's not what we want to see. So why could it be failing? Let me just check the configurations. .3.254, perfect. 192.168.3.1. Do exit, do show run, do show IP interface. Let's try that brief. All right, 10.10.11.2 up 192.16. Okay, so here is our problem. Look at that. That does not look like 168, does it? That's it. Easy thing to do when you're typing fast, like I am. Well, not fast, but not really typing fast. I just got home from work, and it was a 12-hour shift, so I'm a little sleepy, to be honest. No IP address. I'm just gonna take that off, and I could have just copied and pasted it, but my brain is not braining right now, so I'm sorry, guys. Just bear with me here. We are almost done this video, I promise. Okay, and I'll say IP address. So all I did is I said, hey, I don't want this IP address anymore. This would be blank now, and I'm gonna say IP address 192.168. The reason that that ping to the other networks is failing is because I had the incorrect IP for the default gateway for this PC. It would never be able to reach anything else unless that's fixed. So let's fix that. Do right. And now when we ping, it should be fine. Boom. There it goes. That's what you want to see. Perfect. Same thing should occur here. We know 2.1 works. 3.1. Oh man, sorry guys, I had an extra dot here. There we go, that works. And now, let's just, for confirmation here, I want to show the IP routes too, because you see that they're updated. 2.1. Well, I already know that works. 3.1. There we go. So everything can talk to each other. That's basically what the network is. It's just routers connected to other routers, connected to networks, connected to switches, connected to PCs. That's really it. Just different routing protocols, different methods of doing X and Y, really. Do show IP route. So now you can see we have 3 different O's. And if you remember, the O's stand for OSPF. What am I trying to say here? OSPF routes that were gained through neighbor adjacencies. So basically, what we set up is, let's say router 1 said, hey, router 0, what networks do you have? And router 0 is like, oh, hey, router 1, here's my networks. Can I have yours? And then they basically exchange data. That's it. But that's it for the video. Thank you guys for watching, and have a great day or night.